Okay. I'd like to welcome everybody to Google here. If you made it, this is the Brew Robotics Club. If that's not what you want, you can leave. So, my name is Wayne Bramlick, and I am the president of the Brew Robotics Club. The agenda is as follows. First, we will do any club-related stuff, and that will include people talking about robo games and robot block party. Followed by that, we do show and tell, and the primary reason for doing show and tell at the beginning of the meeting is because sometimes people with smaller children have to take their children home and get them to bed because they have to go to school tomorrow. And then after that, we'll probably just take a couple-minute break, and then we'll start our talk. And then after the talk, we will do what we call random access. Random access is we just go around and talk with one another. So, and then around 10, we sort of shush out to the parking lot and continue talking until we all freeze. So that's kind of the agenda. So I'm going to start with Robot Club business. And because we have new bylaws, it turns out we have to vote in our new members. Okay? So.
Not that guy. Keep him out.
Oh, okay. So, we have 4 new paid members, and I'm sorry, I mangle names, so I do it to everybody. Rafael Scholar is 1. James Geidel is next. I'm going to mangle this one. Kawalajit Nepal. Not too good with the Indian names. And Brian Cobra. So, all in favor of inviting these people into the club, please raise your hand. You have to be a member to raise your hand. Okay. Okay. Anybody against?
I need to see their birth certificate.
It's short form or long form? Photoshopped or non-photoshopped? Okay. Yeah. Well, so, welcome. Are any of those 4 people here tonight? Okay. So, when the badge thing comes around, just swing on over here and pick up your thing and take an empty badge and put your name in it, okay? If you are a new member, how many people are here for the first time? Excellent, excellent. Okay, you might want to come to a few meetings and decide that, if you decide you really want to be a member, what you do is you go over to our secretary over there, Bill Benson, raise your hand. He's the guy with the apple. And you say, I want to join, and he bills you about $10. Sometimes he asks for more, but don't give him any more. Okay. And he will let you into the membership roster. The primary purpose of the membership roster is to provide some funds to pay for things that expenses we have during the year, like our website and a few things like that. It's not a big deal. Okay, so now that we've done that club-related stuff, let's go to the discussions of the 2 events that occurred this past month. How many people made it to Robot Block Party? Okay. Does anybody want to say anything about Robot Block Party?
A lot of fun.
It was a lot of fun? Alan?
I found it very useful because I had to leave in the middle, and I came back and I found that a lot of things were destructively tested.
Okay.
So I was able to make repairs on those things, and now I have a much better product.
Very good.
Very well attended.
Very well attended. It was very crowded. And I'm not sure Ralph is going to make it tonight. Ralph was the person who pulled it all together. So in absentia, let's give Ralph a big round of applause. He's not here I appreciate it. Ralph did a lot of work to sort of organize it and make it all happen. And a lot of us were able to get free parking passes, which was really nice because Stanford, you do not want to, don't want to park there without a parking pass. They will get you. Anybody else want to comment anything about the block party? Shadow.
It was fun seeing the kids play with the robot. They'd stand in front of it and have it run around in circles.
Yeah. And yeah.
Oh, I was going to say, I think one of the best robots was made by 3rd and 4th graders. It was called Monster Dog. And it was this NXT motor that drove these PVC pipes, and the thing oscillated on the asphalt, and it had this paper mache head with these tinfoil ears, and it was fierce. But the coolest thing was it kind of had a little secret button that you reach around and press, and I could watch the kids watch each other, and they, the little 5-year-old girl would figure out where that button was and go over and press it, and Monster Dog would go, it was wonderful. You can't, yeah.
There were a lot of children there, so, okay. And how many people are here because they found out about us at Robot Block Party? 2? Okay. So the next big event, which is all part of National Robotics Week, was RoboGames, which I was unable to attend, as usual. And how did we do? How many medals did we get? 2. At least 2.
I got
3 more over there. Okay. Okay. So Sam, tell us about your medal.
I'm not proud. This is a bronze medal for my own event, tabletop navigation, and I got beat by an 11-year-old. And not Shiloh. I got beat by Shiloh, so I'm proud of that. And Alan Marconet, he had in Micro Moose and Duhingus Maximus. Did I say that right? Regardless, this is my award-winning robot. By the way, we're building club bugs on Wednesdays at the tech shop. And this is basically an Arduino-based tabletop robot. It's a servo sandwich, double stick tape. We've got the whisker switches, and basically I just did phase 1, which is go from one end of the table to the other and back. And get stuck. Again, I'm not proud. Okay, so there it is. Buggy 1, doing tabletop challenge phase 1. That is going from one end of the table to the other and back. Micromoose did phase 3, as did Duhingus Maximus. Is Duhingus here?
No, we didn't bring it tonight.
That's okay. That's okay. We've seen it. We've seen it before. Oh,
I just wanted to make one comment. You guys couldn't hear this because you guys were standing behind the metal podium, but I was back in the audience section when they were doing the metal presentation, and some woman next to me says, "What is this event? And look at this. There's 2 shaggy old men and a little girl." I just wanted to let you know.
They liked it though, didn't they? That's the main thing. That's the main thing. Yeah. So, for those who doesn't know what is the TableBot Challenge, raise your
There's
hand.
all sorts of new people. You have to tell them.
Oh my. Okay, the TableBot Challenge is 3 phases. Phase 1, go from one end of the table to the other and back. Phase 2, push a block off the edge of the table. Phase 3, move the block into a shoebox mounted to the end of the table. These are the rules, these are the guidelines. We don't specify the size of the table, the shape of the table, the size, weight of the robot. Run what you brung, okay? And we do phase 1 traditionally in June, the HBRC Challenge. The meeting is all show and tell, nothing but show and tell. This is, although we've had great meetings so far this year, this is usually the best meeting of the year, especially the June one. And it features potluck dinner, robot potluck dinner, and you get extra karma points for bringing in foods with a robot theme. So, what have we had? We've had the wheel.
I don't know if we've actually managed to get the A-OK for a potluck.
Ryan says okay, right, Ryan?
Is it okay for a potluck in June?
Yeah, we'll make that work.
We'll make it work, okay. So
There we go. That's what I'm talking about.
Excellent.
Okay, and so again, on Wednesdays at the tech shop, this is the SIG, the Special Interest Group. We're building these club bugs. They're a lot of fun. We brought a robot to life last Wednesday. Charlie, you out there? All right, Charlie didn't make it, but Charlie had some fun soldering up the club bug. And we've gotten permission. We've got these permission to reprint the Aardbot article by Gordon McComb out of Servo Magazine. I've got all 6 of the series, and that's what we're working with. Hey, Ryan, how you doing? All right. Okay, so, oh, and I know you're concerned. It's like, where's Springy? Okay, I brought Springy out, and I didn't charge the battery, and so she started languishing halfway through the parking lot. I put her back in the van, so if you guys want to come say hello to Springy after the meeting.
We were wondering. Springy is a...
Springy's a member.
Springy is a member. Okay. Now, let's see. So we've got, that's the tabletop. Let's, Bob,
Yeah,
can I get you to walk up here and just put you on camera?
There's a couple of people we need to thank, and one is Camp. Camp ran the
Me too.
well, he ran the Robo Magellan contest, and it's like 5-6 hours, and it's really tedious. He does an excellent job, so I think we should all give Camp a hand. And there's actually 2 other people I'd like to thank, and neither one of them are here. One is Anthony Praktanis. He is our announcer for the firefighting contest, and without him, firefighting wouldn't be the same. And since Tony's going away to college next year, he's thinking maybe not coming to Robo Games. So if you've got any money or anything, you know, we can bribe him. That'd be great, because it won't be the same. So he's not here, but let's give him a big hand. And one other person, Ted, he's on vacation, but he ran also the Micro Mouse stuff. So he was the one that organized the Micro Mouse, got that going. We had a full, I guess a 16 by 16, or
I think we got a full 16 by 16.
Full 16, which was great. There was a robot that got shipped from Japan. The owner of the robot didn't show up, but the robot did, and I believe that robot took first place. We had to run it, but it took first place. Just a hand for Ted for doing that as well. That's great. Let's see. We had in Firefighter, by the way, this year. It's usually won by Tony Praktanis, who's not here. He's getting ready to go visit Stanford tomorrow. But he's usually won. We had 13 events, 13 entries. It was a great contest. So we had a gentleman from England, who's my friend, who flew out just for that. We had the Indonesian team, which took first place again. We got to fix that for next year. Let's see, did we have anybody else from other countries? Mike and Rose, do you remember? No? Then we had Akron, Ohio, had like 3 entries, and
Angel from Spain.
oh right, oh yeah, I forgot. Well, Angel came, but he didn't do the firefighter. But he came all the way from Spain. Is another friend of mine. He came from Spain just to do Robo Games, and he actually entered his robot in the Best of Show and got 2nd.
Silver medal.
Silver
And
medal.
we had a great Robo parade on Prom. We had
Here,
about
I'll hold this, 'cause you
about
don't
8 robots, and the disco bot was leading the parade. It was about 8 of us driving back. Here, sorry.
No, this only works when you do this. It doesn't work when it's so yeah, so he was real pleased with that, and that event actually was sponsored, I think, by Google. Right, Ryan?
Best of Show.
Yes, Best of Show. So we also want to thank Google for doing that as well. And there's one other company that we were able to get as a sponsor this year, and that was Needle Robotics. Camp and Nathan and Dave all work. They sponsored the firefighter. They actually gave us 3 XV11s, thank you, to give away, which I did. So what we did is we put, instead of, if you won first, second, and third, you got one, I thought I'd do something a little bit different, so everybody would have an equal chance. We just put everybody's who entered name in a hat, and we pulled out 3 names. And so the Indonesians won 1, let's see, somebody from Akron won 1, and I think another team from Akron won the other one. So that was kind of fun. It turns out that the XV11s make really good firefighters. And we were demonstrating them in the firehouse, and they worked really well. And so, who knows, next year we might have an XP11 as a firefighter.
Do they fit within the starting size?
Yeah, just barely.
But they fit within the house, but isn't
Yeah.
there like a
Yeah, there is.
size
And,
limit on the
and
robot?
it's like a quarter of an inch of width of fitting, I think. It's really, really close.
So it's just under maximum.
I think it's
We make the
very.
rules anyway, so.
Yeah, I mean, if somebody brought an XV11 and it ran, we'd probably leave them run. So I would be that. So, let's see, anything else?
Will Garage also gave.
Yes, Willow Garage, I think, sponsored
Robo Magellan.
Robo Magellan, and, you know, we want to thank them. I know Tony's not here, but he works for Willow Garage, so. That was
GLaDOS
really
got
good.
the gold. GLaDOS, the UCLA robotics group, got the gold medal in Robo Magellan. They touched all 3 bonus and got the goal, and their discounted time with the bonus cones was down to like 40 seconds. It's actually a 10-minute run.
Wow.
3 bonus cones in the goal. Last year they didn't reach the goal. This year they did. Unfortunately, there was only 1 robot that actually made it to the goal this year. But it was a lot of fun. Everybody had fun trying. And we'll do Robo Magellan at the HBRC Challenge in June. Did I mention that?
No, you don't.
Yes.
That
yes.
sounds fun. So firefighting was, the Indonesians took first. They've taken first, I think, the last 3 years. I was fortunate to take second. And third, I think, was somebody from Akron, Ohio. So that was a lot of fun. And then we had also a balancer race that Ted and I had started. We had 3 entries, 2 from the Mexico team and 1 from Akron. And the Akron team won this year as well as last year. And then, of course, the Mexican team took second and third. But they had some really good balancing robots. So we had a little problem. I don't know, at the last meeting we had a little Google Droid. And it was standing next to me officiating. And the Akron balancer comes along and just turns and runs right into him, knocks him down, put a gash in the back of his head, really bad. So they got a Band-Aid and put on it. That was very nice. So now our droid has a Band-Aid in the back of his head. So anyway, all was good. Let's see, my 3 robots, I entered, I think, 4 or 5 contests, so I was able to get second in firefighter. Ted and I and my friend Michael, we entered for the first time our humanoids in the humanoid soccer, and we beat the Taiwanese, and then we went up against the Japanese for first place for the gold medal, and they're good because, well, one of the humanoids that we have, a couple on the team actually worked for that company and helped develop it, so they had a lot of experience and stuff. And I stopped counting after we got like 12 goals. We didn't have any. Oh, sure. Yeah. It's one of the newer ones. Unfortunately, I forgot the remote, but it's got 22 degrees of freedom, and they really want, this one's a Condu 3, and they want this one to be the #1 humanoid in the United States. And so far, I think Ted and I are the ones that have one. So, but they're a lot of fun. Ted and I had a lot of fun trying to do the soccer because we had no idea what we were doing.
So you guys didn't know that you bought it and
Yeah,
it.
well, yeah, it took a year to build because everything was in Japanese. There's no English. That's what happens when you buy in Japanese. Anyway, and then I went up, entered the Walker Challenge, and I got the bronze in that. So that was kind of fun, and that was filmed, I think, by the Mythbusters guys. One of them, I forget which one was there, and he was kind of Grant. That's right, Grant was there. So that was a lot of fun. So it was a good event, and next year you got to come. Next one.
Okay. Let's see. I think the next event is going to be Maker Faire. I don't think we managed to get our request in on time, so I don't think we're going to have much of a presence.
One more thing.
Oh, there. You got to come up here and use the mic.
Alan Dowling here with his PR2 Lite and the American High School group are really be congratulated. You guys went in? Did you think
No, they didn't. We
Dude,
never even
man.
saw the judge.
you were entered in Best of Show.
Yeah.
They built a PR2 Lite.
Oh.
you know, using Ross and everything. It was really wonderful.
It did the arm mimicking thing similar to, and Pi Robot was there too, also in the PR2 booth.
Very good.
Can I just
Well,
ask,
please bring it in.
Yeah.
If you can. No.
this is so you built your own, like, sort of another PR2, not the Willow PR.
Right. It didn't cost 400,000.
Yeah, that's what I'm thinking.
But it's got two lidars, including a Mito lidar. It's got a Connect on the head.
You got it running in ROS.
It runs ROS and with navigation software. It was, it's pretty cool.
It was
But
rocking.
I think we're going to be seeing a lot more Ross robots in
could
the
you,
next few
do you
months.
think you'll be able to bring it to the club sometime?
yeah, it got pretty beat up as a result of these things, and PR2 gave us a spike in the electricity when they caused a power outage.
Oh.
And killed one of our microcontrollers, and also had a bunch of kids playing with
Yeah.
it.
There was a nice photo of the Ross family robots.
Yes, so if you go to the Willow Garage blog, you'll see all the Ross robots there, including Valtrop's Pure Light and Pi Robot.
I was just going to say, Google will be at the Maker Faire.
You will be
We have a very big booth this year. So if you've been in the past, you've seen, actually we weren't there at all last year, someone just forgot to do something there. And in years past, we had like a 4x8 sheet of plywood on some sawhorses with a laptop. Pretty lame. So this year, we have a very big space with SketchUp and lots of robots. Lots and lots and lots of robots. ROS robots, Android robots, robots designed in SketchUp. It's really cool.
So there's a relationship between SketchUp and robots?
SketchUp is a cool place to design a robot. It's a cool app to design a robot. So you could design it, then you could print it on a laser cutter, and then you could hook up Android to it.
Hey Brian, actually my two robots leaning against the wall there were both designed in SketchUp.
That's awesome.
I love it.
You should send us the designs and we'll put them on the display.
Okay.
Absolutely.
Yeah, I'll send a question about SketchUp.
Excellent.
Get in touch with you later.
Sure.
Excellent. Okay. Go to the Google booth at Maker Faire, and maybe next year we'll do a better job and get a little mini booth for HPRC. We're trying. Okay. Anything else that's kind of club related that I forgot? Usually this is where Camp raises his hand and says something.
Would you please name the people who spoke?
Spoke.
Yes, I didn't get the spelling. For the people who spoke so far, could you perhaps just pronounce their names slowly?
There's some.
Well, like for instance, this gentleman, is his name Kemp or Camp?
Camp
Here,
PV.
here, dude. No, thanks.
Okay. I'll tell you what you do.
Okay.
Go up after in random access.
Sure.
And just read their badges. It's a great way to introduce yourself, okay? Thank you. Let's see. So now we're going to move on to the show and tell portion of the meeting. So who has...
Was that the first?
That was our first.
Yeah.
We just had first steps here.
First steps? Cool. Very cool. So Violet is our youngest member right now.
That is a cool robot.
So, and she's all happy. Yeah.
Balancer, right?
Oh,
Balancing robot.
Yeah. Okay. Too bad we didn't get that on video. Okay. Everybody who wants to show a robot, just give me a quick raise of the hand so I can try and 1, 2, 3, 4, 5, 6.
I'll be doing mine during my
Doing it during your thing, okay.
I'll do my
So
demo during my talk.
what I'm going to tend to do is just sort of sweep from right to left. So that kind of gives you an idea of what order we're going to do it. Does anybody need any significant setup for their show and tell?
We could use a mouse if someone has a mouse.
They would have USB mouse.
Is it?
Yeah. Oh, yeah. Yeah.
Okay.
Well,
So,
at the trackball.
okay, so why don't we start with you? I don't know your name yet. Yeah.
Positive.
Ozzy. Okay. Here, take this.
Get some power.
I'll hold it while you.
I need a table. Maybe this
You can use this table. You don't mind if I move
Is,
it?
Alan, do you mind if we move yours?
Yeah.
Okay. Strong enough?
Well, okay. Cool. Now, for those of you who remember, Bob Smith here gave a talk on Chumby robots. So now we have 2 Chumby robots here at the...
Stand up by yourself,
So.
Right. Do I need the microphone?
Okay.
So my name's Osman, for those of you who don't know me. And I want to thank Ryan for reminding me about SketchUp. It's something I have been wanting to talk about each time I've shown a robot in the past. It's a wonderful tool. It's a free CAD tool. You know, maybe it doesn't have the power of you know, AutoCAD or SolidWorks, but it's a great way to get started. You know, if you're looking for something to do your mechanical design. And like I said, I've used it for both of these robots here, as well as my tabletop challenge robot that I showed last year.
You want me to hold that while you... Sure. Fiddle.
Okay. No, I think I'll be able to. Is there like...
No, well, there might be.
Okay. Anyway, so this is Blinky, and I'll show you why. You'll figure out why he's called Blinky in just a minute if you don't already know. I have 2 versions. So the difference between the 2 versions is in the electronics. So I'll talk about this version first. My goal of building this particular robot was to create a balancing, Chumby-based robot with as few extra parts as possible, other than the Chumby. Okay. So for those of you who aren't familiar with the Chumby, I know there's been a lot of discussion on the list about it, but it's basically a Linux-based computer that you can program in C, that you can get for $50. And it's a great controller for a robot. I'm gonna go ahead and plug him in because he takes a couple minutes. To boot up and lose his head. Okay, so obviously there's a Chumby out here. In addition to that, all there's a power regulator, there's an H bridge, and there's a gyro, which I mounted inside the case of the Chumby. The only output from a factory stock Chumby is a USB, which is on the back, but that wasn't very much use to me. Fortunately, the schematics for the Chumby are open source, and they're available at chumby.com. You know, and the processor that they use in this thing is a Freescale IMX 233. It's an application processor, and has some really nice features that are really useful for building robots. So with the schematics in hand, I was able to find some PWM outputs from the processor, and with a few magic commands to the processor, and some soldering of some very small wires, I was able to bring them to that back of the Chumby here, put a little connector on there. So I used the PWM for motor speed control. I was able to find some unused general purpose I/O pins, solder to those, use those for motor direction control. And this processor also has 6 analog inputs that you can use for analog to digital conversion. Unfortunately, they're all used by the Chumby for things like the touch screen. You know, there's a microphone input. So I decided, well, for this Chumby, I don't need a microphone input. So I removed the RC filters from that A to D line and hooked it directly up to the gyro. So now I had my gyro sensor. There's an accelerometer built into the Chumby, so I use that. So I combined the gyro with the accelerometer with the Kalman filter that I implemented in C, and using the pit loop to control the motors. So that's that, and hopefully it will balance.
One question, you didn't mention if you have encoder feedback wired up.
So the question was, do I have encoder feedback? And the answer is no.
Oh.
That would be really nice to have, because this guy tends to wander quite a bit. There are encoders on these motors, and that's an improvement that I want to make in the future. There are some more general purpose IOs that I could have used for that purpose, but this was just kind of a proof of concept, and I didn't want to take the effort. So let me turn one. So we'll just hopefully do a little quick balance here.
Stand back.
I'm sorry, I'm watching. Okay.
Now, he does have a battery pack. He does have, I kind of ran out of battery packs. Again, this guy was just a proof of concept. So he's tethered with this little leash right here, but it actually comes in handy because it's going to keep him on the table. But I think, the tilt of the table shouldn't make any difference, but if I turn it sideways. But anyway, you kind of get the idea.
Very good.
How many
It's not balancing very well, but
are you recording only the motion displacement or the difference from time period to time period, the first derivatives?
So I guess let me take the microphone back. Yeah, he wants to go forward, so I'm not exactly sure what the issue is, but I'll have some videos of him. Yeah, I probably need to tune my bit parameters a little bit. I have a website. Sorry, I'll get to your question in just a second. So I have a website called ozbots.org, ozbots.org, where I documented some of my Chumby hacks, how to get to the PWM outputs, general purpose IOs, and that kind of thing, if you want to play around with your Chumby. So what did I measure? So there's no wheel encoders, so I don't have any measurement of velocity, so the only thing I'm measuring is angle. And I have, right, well, the gyroscope measures angular displacement. So I have to dial in the angle, before I do the demo, and I guess I had dialed it in a little too forward, so it's going to keep moving. There's nothing to keep it to stop from moving because I don't have the wheel encoders.
Didn't you say there's an accelerometer in the Chumby?
Yes, the Chumby comes with an accelerometer. It's another Freescale part, MMA 7000 accelerometer. It's on the Chumby's I2C bus. It's relatively easy to get to. You just need a little I2C programming.
Does that give you the direction that it's moving? Or?
Well, no, it doesn't. It gives you, I'm using, in typical balancing fashion, you need both an accelerometer and a gyro. And you have to fuse both of those sensors to come up with an angle. The accelerometer is useful for static calculations of tilt based on gravity. Unfortunately, there's just a fact that accelerometers are quite noisy. And they're also subject to noise from the robot itself moving if there's going to be some acceleration, some lateral acceleration. But in addition to that, you have a gyro, which is very accurate, but it tends to drift. So 1 minute, this will be registering as 0 degrees. A minute later, it'll think that this is 0 degrees. And if you don't correct for that, the robot's going to fall over. So you combine the best features of both the accelerometer and the gyroscope using the Kalman filter, and you come up with an angle. So, okay, sorry, I'm taking too much time.
We need, yeah.
Okay. Okay, I will. Can you have 1 more minute?
Well, why don't you boot that, and we'll let you slide in after the next presentation, okay?
Okay.
So who's next? I saw somebody.
That's very.
I saw somebody.
Can we go?
Sure, you can go.
Michael, our webmaster. And our program chair. Sure.
And Rose, our program chair.
You want to start talking about it?
This is Roman A. Round, and he's our. Oh, sorry.
I'm gonna make you mine.
This is our Robo Magellan robot. So this year we finished putting it together. We didn't really get much of the software done, so pretty much went straight forward until it couldn't go forward anymore. We're having some problems with the motor control. It did move.
It did move.
So, and nobody would have known it didn't have
beautiful,
GPS
too.
either. So, but.
Just talk about the press thing over there.
It's kind of facing the wrong way.
You turn the table.
Oh. Okay. This is custom designed with with Bob for using the PVC tube for, we have our batteries and electronics in here. We're using pretty much everything is off the shelf except for one board for reading the sonar sensors. And is there anything else in that?
Compass, I guess it means.
And the compass. And everything else is USB to a mini ITX that I got from Embedded Systems Conference a couple years ago. It was just sitting on the shelf. So that's the main brains of our robot.
So it's running Ubuntu, Linux, and it's running Ubuntu, Linux, and basically we're writing just an application that will do the GPS navigation for Magellan. So right now we got it so that it can actually, we can see the sensors on the screen. So basically we're just BNCing into the machine via wireless.
Bluetooth, Wi-Fi, right?
Yeah.
Can you point that over?
I'll show people later too if you want to come closer after the after the presentation. But we can actually control the robot right now too. So we'll put it on the floor. We'll control it a little bit.
So we have a camera, a CMU cam in the top front, and then we also have some sonar sensors on the top and a nice bump sensor that Bob designed on the front. And we have one sonar on the back as well, if it's still there.
What's the big box?
That is the CMU cam. So
That's the one on the tail.
that's where the mini ITX computer is.
Seems like the batteries are mostly dead on it, but you get a little boost.
Does it have a compass?
It's on pivot right now.
Yeah, it does. It does. Can you make it go straight?
So it's
it
like a
looks
stegosaurus, the brains are in the back.
Go forward. It's trying to go forward, but it just doesn't have enough juice. But
is it like a sonar in the circular thing? Or?
Yeah, we
switch
have
over to sonar.
one sonar in the front and then a sonar on each side right now. We might add another one on each side angled. But that's where we figured we'd start for this year's Robo Magellan. So.
Excellent. We'll continue with Ozzy. No, he's preparing.
Yeah, I can see some stuff set up.
I'll try and talk faster this time.
Okay.
Right, so now you can say, hopefully you can see why this guy's called Blinky. I knew with the other robot that it was just going to be a proof of concept, and I really wanted something a lot more fully functional. So the main difference between this robot and the other robot is that it has a robot controller board on it called the base board, which is from Design Peripherals. That's Bob Smith's company. See Bob up there. So Bob gave a talk on the baseboard a few months ago, and I said, that looks like a nice robot controller. So I've been using it for several months. I guess I gotta say that, I really like their products, Design Peripherals products, and the support of those guys has been great. So a lot of thanks go to them. So the robot controller board takes care of the communication with all the peripherals. So for example, it takes care of the PWM. It can read the wheels, the encoders on the wheels. It has bus interfaces like an SPI bus. So it can control your servos, anything that you might want to do for a robot. It offloads all that from the processor onto the robot controller board. So in addition, their company also sells some little hardware boards that fit within the form factor of the base board, so you can make a nice little stack of electronics. They make hardware peripheral boards such as a 7-amp H-bridge, which I've been testing recently. They've got an A to D converter. Again, all the different kinds of boards that you might need to control your robot. So that's the main difference between the two robots. And again, this robot still does not have my wheel encoders hooked up, but he does a little bit better job of not wandering off. Let me go ahead and get him started.
Yeah.
Okay. A little bit better. I still have a little bit of work to do on pitch parameter tuning. But without wheel encoders, that's probably about as good as it's going to get. So hopefully for the next meeting, I'll have the wheel encoders hooked up. They'll be moving, dancing, doing all kinds of things. One more comment about the baseboard. Sorry, real quick. The baseboard is still a relatively new product, and the peripheral cards that Demand Peripherals are creating, they're looking for beta testers or early adopters. One of the advantages I've had of using this system is that all the cards that I needed for this robot, they've given me for free. As long as I test them out and get some feedback. So a few months ago, I bought a 7-amp H-bridge unpluggable for like $40, but they gave me one to test out for free. So it's a good program to get into, and I think they're still looking for people to sign up. So if you're interested, if you're building a robot and you want to do some testing and get some hardware in return, talk to Bob after the meeting. Why don't you raise your hand so that people know who you are? Thanks.
Thank you very much.
There was some question about whether you could do a PID, a balancing robot, under USB. Was that a problem for you?
Well, that sounds like a setup. But actually, no. And to be honest, that was one of the concerns that people had raised at Bob's presentation a few months ago, is that the interface between the Chumby and the baseboard is through USB. And people were saying, oh, you can never do a tight PID loop with the latency involved with USB. But it turns out actually not to be an issue. It's balancing. So, pardon?
What's on the baseboard again?
The baseboard is this square 4x4 inch.
What chip is it?
Oh, it's an FPGA custom designed by
Guys. Are you saying you're doing the PID logic as well as the Kalman filter all in the top processor?
That's correct.
And so you're doing all sorts of fast, low-level back and forth with the
over the USB, yes, right. To the baseboard, which handles just the interface.
Simple devices with other USBs lagging them, so that's probably partly why it works well, right?
I think it's more sophisticated than that.
It's actually a very sophisticated device.
What's your timing on the USB stuff?
The delay is probably on the order of 2 to 3 milliseconds each direction. So I've got a timing loop running of about 32 milliseconds. So 10%, I've got a 10% overhead that's just not doing anything, but it seems to work.
The key thing is they're transferring a lot of data each time, so that's what makes it work. So good, we finally got to see the FPGA doing some real robots. Excellent. Okay, let's do the next one. Who is this? What?
Charlie, you got your robot? Bring
Charlie?
your robot up here. Bring your robot up here.
Where's Charlie?
Now, come on. Come on, now. Hurry, everybody's waiting on you. Watch your step.
So we're going to make Charlie.
This is Charlie. Charlie's built a club bug.
Excellent. Excellent.
Speak loud.
So did you have fun?
Huh?
Did you have fun?
Yeah.
Okay, good. Can you turn on? There we go.
All right. Hey.
You like soldering, Charlie? You like soldering? Soldering's right.
Okay.
We built this at the tech shop at the SIG. This is part of the club bug group, and he's got the basic bug there. We built that in just one evening. That's his daddy thing there, too. All right. Thank you very much.
Okay. Who's next? Okay. Now, I saw some hands up there. Alan, I know Alan raised his hand. Oh, I missed you. Okay. We'll let Alan go first, and then you can come on down, okay?
So I'm starting a new movement. Instead of steampunk, I don't know what I'm going to call it woodpunk, I don't know. Anyway, no, actually I started studying Da Vinci because, I started studying Da Vinci because I just like the way he would think. And one of the problems we always have to solve in robotics is every time we add a degree of freedom, we add a motor. And motor adds weight, and then you need more batteries. So eventually you have a robot that can't move and do anything. So in a lot of these Da Vinci devices, he had one input, i.e. a human crank, that would do 5 or 6 different things. So I started looking at these machines to figure out how you can get multiple power takeoffs off one input to do multiple things. This is my 5th DaVinci machine that's really just doing, it's a mirror polisher grinder. It's using 3 gears to get 2 motions. And then we had or was it 2 meetings ago, we had the people from Brew Robotics. They had a robot hand design. So my thing is, what would DaVinci do? How would DaVinci design a robot door opener? And this is what I came up with. So the idea is I have just one actuator on my robot that just pushes something forward. So and then I'll just mount this a drill, commercially available drill with a string. So when the drill goes all the way out, it engages. So as it engages, the fingers close up. It twists and closes up onto the doorknob. And then when it can't close up anymore, it turns the doorknob and cranks it up. So,
thank you very much. Okay. What? Oh, we got another balancer. We are really cleaning up on balancers recently.
All right, this is Molly. You keep an eye on her?
I'll keep an eye on her.
She won't stay there long.
Okay.
Well, I should mention, the gears are done in SketchUp.
So that's just Molly standing around. And she has an autonomous mode, but not on the table. So sorry for everybody who can't see. So she should. There we go. So she's got ping sensors on the front, and she has to look up and down and make sure she doesn't hit the dog or the chair or whatever happens to be nearby.
Nice. Oh, look at that.
Excellent.
That's great.
The key that got this, I think you've seen Molly fall down several times. The key that got her going was Ted's CH Robotics IMU. So I stripped out the gyro, the accelerometer I had in there, put that sucker in, and she kind of just balanced by herself.
Very good.
What's that disc in the center between the pings? It's a webcam, so I can run her in another room and watch things. I don't do anything with it. It's for fun. You know, I can't. The robot doesn't talk to it. But it's just a webcam.
So you can log into the webcam.
Yeah, I don't have it turned on right now, but I can.
Most excellent.
Great balancers in one night. Excellent. Okay. I think there was some more, 1 or 2 more ones. Maybe not? Nope, there's one. Okay.
Brian. Hey.
Yay.
Another club bug.
Yeah. This one doesn't do much yet.
Well,
Does it move?
But it does move.
We're easily amused.
So, this one I've just calibrated for forward, backwards, and a couple of turns, just to test it out. And that's all it does so far.
What are you using for your drive motor controller?
So, working with Camp, picked the packet, said, pick up a couple servos, but I found this chassis at Jameco, and it came with 2 wheels and motors and a battery pack, so I said, all right, that looks like a good deal, but now I'm deviating from the design and being my first robot and not knowing what the hell I'm doing and not remembering much of my undergrad. I got into the SIG meeting, I'm like, oh crap, I got 2 inputs, not 3. So thanks to the tutelage of some of the older members, they're like, just go get an H-bridge, you'll figure it out. And I did, and sure enough, it works. I've got an H-bridge that drives the 2 motors and program the Arduino board to time the inputs so it can do a 90-degree turn or 180 or 270 and forward and backwards. So now I need some advice on sensors so I can figure out where the edge of the table is.
What is it, that 75ONE?
I don't remember. I've got it on my phone, I can show you.
That's all right. Okay.
Were there any more show and tells for tonight? Another one.
Just a real quick one.
Come on. That's what it's here for.
So, kind of on the bug bot kick myself,
Good.
actually.
That's
We
what
did
it's
a
there
little
for.
hybrid kit. I'm still sorting out getting my aiming of my proximity sensor and then interrupting movement or deciding to move forward or backward. I don't program a lot, so it's been a bit of an experience. A bit like what the last gentleman brought up, I went ahead, this wasn't from Jamco, that was from Cute Digi, but it's the same wheel kit, it's Tamiya wheels. And then this metal kit I got from Cute Digi as well. The combo was like 30 bucks. I got an Arduino Nano, and then the SparkFun Rob. It's an H-bridge, but it's doctored up and all pinned out, so you just turn it on.
Is that DF Robot?
DF? No, it's Link Sprite based. But this whole kit, including the proximity sensor from Sharp, I figure it cost me about $100. So pretty spiffy. As soon as I get some downward sensors, I'll take it on the table.
Yeah, go for it. Any more? Oh, we got another one. Come on down.
All right.
Oh.
All right, I guess I'll just show this really quick. I discovered Arduino about 6 months ago and created this little guy. I wanted to make it look really good. I spent probably close to 20 hours prototyping, designing it, finding the case for it, programming it to have different patterns and things, and decided I wanted to go on to make a robot. And I spent hours and hours and hours on this guy. Well, exactly about 3 hours. So I call it JumpBot, and all it is right now is a basic avoidance. So it just goes forward. I've got rubber bands on the little wheels to keep it, give it traction, but one fell off, so it's not really working right now. It's supposed to turn left. In fact, this morning it had a glitch and it had a NASCAR syndrome, which was going left or left. So it is working if I attach that little rubber band, but
Okay. I'm trying. Any more show and tells? I think we managed to reach the end of the show and tell. Okay. Does anybody have questions about the club? Any questions?
What is our total number of memberships?
I think we're up to 54. 55? 55. Okay. So after you've come to a few meetings, you might want to think about signing up. It just helps the club out. All you get is a badge, but you know, it helps.
Do we have any graphic artists who would want to make signs that we could put out when we have these meetings?
Anybody graphically inclined? Don't look at me. I'm not graphically inclined.
Well, yeah, I would just say if you like doing simple artworks, simple logo and an arrow, just something that we could. We have so many new members. I'm noticing every month, and it's not easy to find your way around Google Campus. I'd be happy to put out signs that say robots this way.
Okay.
You need them in paper or virtual?
Whatever you would. I mean, I could print 8.5 by 11s, but if somebody wants to print something a little bigger that you could actually see before you get to where you know you need to be, I could do that.
Get our poster in.
Yeah, we should ask, Professor Katz, what happened to the poster?
Where's Dr. Ed?
He didn't make it this time.
We could put a banner in our budget also.
What?
A banner.
Banner? Okay. That's part of the reason why we charge dues is to do
For Maker Faire.
Maker Faire and
games and stuff like that too.
Okay. So, given that we're talking about a banner, does anybody want to sign up to be the banner person? You're willing to do the banner? Okay. Talk to me after the talk and we'll figure something out. Okay.